We're going to try to find the voltages in this circuit using nodal analysis. The first step in nodal analysis is to number the nodes. So we're going to number the nodes in this circuit, and we can see that we have one node over here, node number 2, another node over here, node number 4 right here. Then the following step is to find a reference point. The reference point is the one that has more branches connected to it, so this will be our reference point. Then the third step is to assign voltages to the nodes. Assign voltages to the nodes. So we have node 1, voltage B sub 1, node 2, voltage B sub 2, node 3, voltage B sub 3. No voltage is on the reference node. And the fourth step is to just put the polarities or assign the polarities. Well, the reference node has a negative polarity, and each of these voltages then with reference to the ground will be positive. So positive B sub 1, positive B sub 2, positive B sub 3. The fifth step is to find the numbers of equations that we need to solve for this system. So number of equations, the numbers of equations to solve the systems is going to be equal to the numbers of nodes minus 1. Since we have 4 nodes, one of them is the reference, so it's going to be equal to 4 minus 1 is equal to 3 equations. That's all we need to solve this system. So let's start by finding the first equation, and we're going to find this first equation at this node, that is node number 1, where we have B sub 1, we have B sub 2, B sub 3, and still this is the reference node right here. So we're going to apply Kirchhoff's current law at node number 1. And we're going to apply summations of current going in is equal to the summations of the current going out. And the current that goes in, this is the current that goes in, this is 4 amps, equal to current that flow out of the node through resistors. That's the first one, is B sub 1 divided by 2. The other current that flows out of the node is the current that is going to be B sub 1 minus B sub 2 divided by 2. So 2 times 4 is going to give us B sub 1 plus B sub 1 minus B sub 2. So we multiply these two on the other side of the equation just to leave this in a better form. So we have that 8 is equal to 2 B sub 1 minus B sub 2, and since we also have a voltage B sub 3, we can just say that 0 V sub 3, and that's equation number 1. Now in order to find the second equation, write a Kirchhoff's current law at node 2, and the same, currents going in will be equal to the summation of the current going out, and we write the first current out of this node is B sub 2 divided by 2. This is a 2 ohm resistor. The next current that we're going to consider is this one, going from B sub 2 minus B sub 1 divided by 2. Now if you can see, currents are flowing out of node 2 going to node number 1, and it's positive B sub 2 because we use passive sign convention. And the next current is the one that flows out of node 2 into node 3, and this is again B sub 2 minus B sub 3 divided by 2, and everything equal to 0. B sub 2, if we multiply 2 to the other side, we're going to be left with B sub 2 plus B sub 2 minus B sub 1 plus B sub 2 minus B sub 3 equal to 0 times 2, that is 0, right? And so we're going to have minus B sub 1 plus 3 B sub 2 minus B sub 3 equal to 0, and this will be our second equation. We're going to find out equation number 3, and it's going to be at node number 3, and so we write a Kirchhoff's current law at node 3, and we see that this current goes out, so that let's just say that 0 is equal to positive on the right hand side. Then let's look at this the second current. That's going to be V sub 3 divided by 2, and then this current that flows from 3 to node number 2, that is going to be equal to V sub 3 minus V sub 2 divided by 2. So we send this 2 on the other side, becomes negative. We also multiply 2 on the other side, so that we are left with B sub 3 plus B sub 3 minus B sub 2. And finally, this is 4 equal to 0 B sub 1 minus 1 B sub 2 plus 2 B sub 3. And this is our equation number 3.